Hello and welcome back to the lecture series on algorithmic problem solving. This video is about the tricks that are using bit mask and helpful for the competitive programming. Here is the trick 1, where one needs to turn off the jth set bit, or one can say that to remove jth set bit. And how to approach, or what would be the trick for that? Consider an example of n, where n would be 1 0 1 1 0 1 1 0 0, and it is asked to set the z bit. Here the bits which are set are marked by 1 and which are unset are marked by 0. MSB is set, and if you count the position, the first bit would be set, third bit is set, fourth bit is set, fifth, sixth and seventh bit is set. Now your task is to unset or turn off. So let us consider J as 6. This is from MSB point of view, but generally the notations while programming has to be written from the LSB. From programming point of view, it has to be written from LSB. But for our convenience, for understanding, we are using from the MSB. But from the programming point of view, LSB notation, from LSB notation should be used. Now, what would be the mask? Is the question. And output is, this is turned off, remaining bits should be unchanged. This should be 1 0 1 1 0, and this is turned on, so this will become 0, and then remaining bits will be unchanged, 1 0 0. Now if look carefully, 1 and something should result in 0. That something has to be figured out, and going by the definition of how to set bit, earlier it was discussed that for setting a bit, OR operator has to be used. So first consider the OR operation, where this bit has to be turned on and remaining bits are unchanged. And this would be 0, all bits will be 0. Now if OR operation has been used, is to be used, then 1 or 1 will be 1, but look at the indices 3 and 4. Here it is okay, but look at indices 6. It should result in 1, but it is not. Hence, what we need to do is we need to take the complement of this. Take complement of this number to obtain the mask. Now, to take complement means to flip the bits. So just flip the bits, which will be 1 1 0. So except at position 6, remaining all will be set to 1. This is 5, then followed by 0 1 1. 7. This is how it will be represented. Now here becomes the new mask. Okay. Now we have got n and mask. Now which operation should be used such that this output is 0? Looking at this, one should prefer to use AND operation because that will only result in 0. Otherwise, at all the cases, the outputs will be unchanged. Hence, now this is to turn off the jth bit, which is here 6, but from the LSB it is 2 because of the weights 1, 2. We are shifting it by 2 times to get the result here. So n would be n and equal to by j. Here j is 2, 3 from LSB point of view. 3 bits, and then you are taking the complement, which is flipping the bits. That is not operation. And to get that result, we are just doing AND. So this is the trick number 1. Negative number can be represented like by taking 2's complement of a number n. 2's complement can be done by taking 1's complement, which is flipping all the bits, adding 1 to get the 2's complement. So taking number as 44, just flip the bits and assume that it is stored in short data type, which will consist of 8 bits. Then this is the original number. Flip the bits to get 1's complement and add 1, 1, 1, 0, 1, 0, 0, 1, 1. Then addition of 1. Here 1, 1 will 2, carry over of 1. 1 plus 1 is 2, carry of 1. 1, 1, 1, 0, 1, 0. Here last bit signifies the sign of a number, and the mask would then be represented by this number. So n is 44, which is 1, 0, 1, 1, 0, 0. Taking number as n equal to 44 and 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0. Now if an AND operation is performed, ignore the first bit, which is the MSB bit, because that will represent the sign. Consider all the bits and do the AND operation. Here it is 0, 0, 0, 1, 0, 0, 0, 0, 0. So it hasn't lead to any conclusive conclusive point, because we still haven't found out the position of the first set bit. For that case, just do the following step, like, so take a previous number, like consider a number 43 for this case, n minus 1, 43. and check if that performing with AND bitwise AND operation, check that if that is lead to this output or not. Why? Because if look at the binary representation of 43, it will be 1 0 1 1 1 0 1 1. This is the binary representation of 43. And if performed AND operation on this part, here it will be 1, remaining it will be 0 1 0 0 0. We have got 0, so this is not working. So why don't we take the complement of this number, that is by flipping the bits 0 1 0 1 0 0, and then perform the AND operation on this to get the output. Checking and performing n minus 1 to check whether the output is achieved or not, which is 0 1 0 0 0 1 0 1 0 0, followed by a bitwise AND operation. This is 0 0 0 1 and 1 1. So this is the trick. The trick is to write number n as n and equal to bitwise AND, taking the complement of n minus 1. This is the trick to get the position of the first set bit. Trick 3 is to figure out the way in which all the bits in a set of size n can be turned on, and the n here represents the length of bits. Where considered an example where the value of a is 13 in decimal form, and in binary form this can be represented as 1101. Here n is of length 4, and one needs to figure out all way to turn all the bits on. The mask should be figured out. Output will be 1111. Here 1111 is done. Then this performing OR on this will result in this output. Consider another case or another example where a is 1000, which is binary representation of 8. Output should be 1111. For that case, the mask will be 1111. So in any case of length n, the mask is 2 power n minus 1 followed by OR operation. So this can be represented like 1 left shifted by n minus 1 followed by OR operation. Hence the trick is that any number for which the bit has to be figured out will be a followed by OR equal to 1 left shifted by n times minus 1 to get the output as how many, to turn all these set bits. Now moving on towards trick 4. Trick 4 is to figure out the mask value in which the last one bit of n is set to 0. To look at this, consider an example of n having the value of 44 in decimal form. In binary form representation, it can be 101100, and output should be 101, here 0 followed by 0. So one can look at this and see that remaining bits are unchanged. Only bit that is being changed is the last one bit. So that is set bit. Last set bit is to be changed to 1. So for that the mask has to be figured out, and in that case how would the mask represent? If that is the case, then we are setting value from 1 to 0. So let us consider a value here 0, and remaining case the value would be 1 1, and perform AND operation. But is this technique always useful? No. This mask will not work always. So one needs to have a look at another way of representing this mask. In that case, n is even number. Now if n has to be converted to odd number and performed AND operation, then this will not be affected. Why? Because 0 and 1 is 0 0, 1 and 0 is 0. Only case where it will work is 1 and 1, right? So considering an even number, odd number, here the number is 44. Consider a previous odd number, which will be 101011. Adding 1 to this number gives us the original number. So this would be the mask, and performing AND operation on this number will give us this output of 101000. In short, n can be represented like n and equal to n minus 1. This will set the last one bit of n to 0. This is the trick, and this trick is very useful and should also be remembered.